In section 10.2, we'll be going over writing conditional and basic probability statements using Venn diagrams, two-way tables, and tree diagrams. In the first question, it says there are 8,752 teens, ages 13 to 19. There are 6,010 adults, ages 20 and older. Out of all the adults, 59.73% chose vanilla over chocolate. If I know that, I'm going to enter on my calculator that out of the adults, I'm going to times it by the percentage, which would be 0.5973. 6010 times 0.5973 equals 3,589.773. Now in data, I can't have 0.773 of an adult. I'm going to round it up. So this percentage chose vanilla. So I'm going to write 3,590. I'm going to round this. Which means, let's see, they gave us one more thing we can add in there. 4,732 teens chose chocolate. Now I can fill in the blanks. I'm going to do 8,756 plus 6010. That's going to add up to my total. Then I'm going to do my total teens, 8,756 minus 4,732. I'm going to do my adults minus the ones that liked vanilla. And I'm going to total them. So 4,732 plus 2,420, 7,152, and 4,024 plus 3,590, 7,614. I'm going to check to make sure my totals make the same thing. So we have our table filled out. It then says to organize the same data into the Venn diagram that Amara started. Okay, so I have that T is teen, C is chocolate. So I have teens here. Teens that liked chocolate would go in this category because they overlap. Teen and chocolate would go here, which means if they like chocolate and they're not in the teen category, that's the adult. Then I need everybody else that was part of the data that's not represented in these bubbles. So I'm going to do my total. 14766, take away the 2420, take away the 4732, take away the 4024. There are 3,590 people that are adults that like vanilla. That's what they end up being out here. I don't know if you noticed that these numbers match. So we have check, check, check. So the outside number would be the 3,590. Now put the same data in a tree diagram. Okay, I have teens. Teens, there are 8,756. Adults, 6,010. Out of the teens, I then split it up, chocolate, vanilla, chocolate, whoops, these are the adults, vanilla. Using any of these three, we're going to answer the probability. What is the probability that they prefer chocolate? So it doesn't say what group, all it says is prefer chocolate. That means I'm going to write chocolate out of my total. If I write that as a percentage, that's 48%. I'm just going to round. Out of the teens, what is the probability that they prefer chocolate? Four, 7, 3, 2 over the total amount of teens. Four, 7, 3, 2 divided by 8, 7, 5, 6 is 54%. Out of the people who prefer chocolate, where's the total for chocolate? Prefer chocolate, how many of them are adults? So I'm going to write that out of the total that prefer chocolate, the adults, there are 2420. 2420 divided by 7152 is 34%. I'm going to round up. What is the probability that they are a teen and prefer vanilla? Teen and prefer vanilla out of the total. They didn't specify that it was a specific group with the line. Four two 4024 divided by 14,766. 27%. Okay, now write the statements to describe these probabilities. 2,420 over, so that 2,420 are the chocolate, given the 7,000, oh, I lied, that's the adult. The top is the adult, 7,152 is out of the chocolate. Uh, 14,760, that's the total. 2,420, that's the adult and chocolate. There's no bar because the value on the denominator is out of the total from our table. Which flavor do you think is actually the favorite? In your own words, explain which one and why. Example 2. Some studies suggest that students that like math also like music. To test that idea, Luca did a survey of students in his school to find out which math or music courses they were enrolled in. He used his results to create the following Venn diagram. Find the following probabilities. Given that they were in math, actually, I'm going to do a few totals just to make it a little easier. All right, so those are my totals pulled from the diagram. Okay, math. Math is right here, which is a total of 30. Out of the 30, how many of the students liked music? "13" out of the math section. For the next question, it requests music and math. There's no bar, it's just how many students like music and math. That is the 13 out of the total. What is the probability that they don't like? So not math or music. That would be the 45 out of my total. And if you want to enter the percents, you can. You just enter this on your calculator, move the decimal 2 spots. Use the Venn diagram to respond to the following problems. I'm going to write my totals. I have a soccer total, pet owner total, and a total. Okay. Now I get to answer questions. How many people said soccer is their favorite sport? That would be 35 plus 50. There were a total of 85 people. How many people? 85. It's not a probability. I'm just defining how many people that pick soccer. How many pet owners are in the data? Pet owners. That would be 50 plus 26. 76 people own pets. How many of those who don't own pets chose baseball? Baseball's not even in here. How many of those who don't own pets chose baseball? So we don't want anyone that chose soccer, and we don't want a pet owner, which leaves out 30. There are 30 people who don't own a pet and chose the other sport, which apparently was baseball. What is the probability? Now we're getting into fractions. Probability, be careful. That a person would say soccer is their favorite sport. Probability of soccer. That would be 85 over my total. That is the fraction you would enter in. If they want a percentage, I would round it to 60%. I'm just an estimate, about 60%. What is the probability that a pet owner would say soccer is their favorite sport? This is where we are starting to separate our data into sections. So what is the probability that they prefer soccer out of the pet owners? Well, there are total pet owners, 76 of them, and 50 said that they prefer soccer. Which, when I enter that in, as a percentage. Or you could say 66% and round up. Oh, that was a typo. This was from the other page. So we can check that off. That's done. Example 4. We are given a Venn diagram. For math, we have 65 plus 40. For ninth, we have 40 plus 35. And for the total, we have all right. How many people said math is their favorite subject? Just wanting people, not probability. So how many people chose math? 105. How many 10th graders are in the data? Ooh, that's tricky. If this is the 9th graders, that means that this is a 10th and this is a 10th grader because they're outside of the 9th grade bubble. So I would say 65 plus 25 gives me 90 people are in 10th grade. How many 9th graders chose science? 9th graders that chose science. Well, this is 9th in math, which means that's not what I want to do. This is 9th and science. What is the probability that, here we go, probability, that a person would say science is their favorite subject? Okay, how many people are in science? Math, this is a science and this is a science. So I'm going to say 35 plus 25 is 60. That's 60 out of my total. What is the probability that a 10th grader, they're singling out 10th grade, would say science is their favorite subject? So, out of the 10th graders, there were 90 of them. How many of them chose science? 25 out of the 90, which is about 28%. Right, now we're just going over filling in tables, just completing tables. We're not going to be evaluating data. Hopefully, so far it's made sense how you do that. To fill in a table, I have 85 and 50. To find this missing block, I'm going to type in 85 minus 50. Then I have 30 plus 35 will make my total. Then I have 65 plus 76 will make my total here. Then I can find 141 minus my 85. And I can do 76 minus the 50. To fill in the blanks. Alright, I have 85, 50, 50, 60, 70, 80. That would be 35 here. I have a 35 and a 10, that adds up to 45. 45 and 60, 6, 7, 10, that's 105. 105 minus 85 is 20. 60 minus 50 is 10. 20 and 20 make 40. That would add up to 30, 40. That's 50, which means this would have to be a 10 to make 60. 10 plus 10 is 20. 60 to 130 is 70. 70 minus 10 is 60. 50, 40, 30, 20, 10, which makes 35. Whoops, that was wrong. My bad. 15 plus 10 is 25. As long as you can fill in the tables, it doesn't matter what order you go in, you should be good. Example 6. Use the information provided to make a tree diagram, two-way table, and Venn diagram. Data was collected at the movie theater last fall, not about movies, but clothes. 6,525 people were observed. That's the total. 3,123 were wearing shorts, and the rest were wearing long pants. And the rest were wearing pants. 6,525 minus 3,123. 3,402. 45% of the shorts were made of denim. So shorts. I'm going to see what 45% of 3,123 is. I'm going to round this. Let's round it 0.35. I'm going to round it up to 6, so it's a full pant. So that would make Made of denim. Shorts were made of denim. I could either subtract this or I could times it by 45% to 100 would be, let's see, 4, 55%, 1717. I think that's the one that we should bump up. So I'm actually going to write this as a 5. Sorry. I'll leave that as a 5. And then that way, 3123, subtract 1405, 1718. That one should be the one that rounds up. Okay, now it gives us 88% of long pants were made of denim. .88 times 3402 is 299. That's gonna bump the 3 up. I'm gonna round it to a 4 because this is bigger. When it was 0.35, it was small, so I shouldn't have rounded it. This one I should round up. Long pants were made of denim, which means 3402 minus 2994 is 408. Then I add them up for the totals. Total amount of denim is 4399 and 1718 plus 408, 2126. And I am going to, let's see. I'm gonna check it and make sure that my denim add up to my total. Okay, we are good. Those are all the values. My two-way table is done. Now I'm going to do the Venn diagram. Shorts and denim, shorts and denim, shorts and denim. 1, 4, 0, 5. That means denim pants would go here. 2, 9, 9, 4. Shorts that are not in the denim circle. So I've checked, check, check, 408 goes on the outside. Those are the not denim and not shorts category. All right, total shorts. So Venn diagram, done. Total shorts. Total pants. Out of the shorts, there were 1, 4, 0, 5. Not denim shorts, 1, 7, 1, 8. Pants, I had denim, 2, 9, 9, 4. Not denim pants were 408. So we just fill in our tree diagram. Tree diagram. Next question. What is half of 1/3? 1/6. What is 7/12 as a percent? 7/12 would be written as 0.583 58.33 repeating. So when I write it as a percent, I'm going to write 58.3%. What is 1/3 of 2/5? 1 times 2 is 2. 3 times 5 is 15. Write 1/6 as a percent. One over 6 is 0.166 repeating, so I'm going to say 16.6%. What is 1/4 of 4/7? That will give me 4 over 28. If I reduce it, that would become 2 over 14 or 1 over 7. 1 over 7 is the best I can reduce it to. What is 52% of 1,200? I'm going to type it in as a decimal point. 52 times 12000 624. What percent is 5 over 8? 5 divided by 8, 0.625. As a percent, 62.5%. What percent is 32 out of 160? 32 out of 160 is equal to 0.2. When you move the decimals 2 spots, that will make 20%. What is 35% of 50? 0.35 of 50 is 17.5. $60 is what percent of 250? 60 is what amount of 250? 24%. 70 is 60% of what number? I'm going to do this one a little bit differently. 70 is 60% of what number? If you don't like this, you can write it as 70 over x equals. Percentages are out of 100 if you don't like the decimals. I think I like this one better because now I can cross multiply. 60x equals 7,000 divided by 60, and we get 700 divided, or I'll just type in 7,000 divided by 60 is 116.66 repeating. If it wants it as a fraction, it would be 1/16 and 2/3. So just be careful if it's asking for a decimal or a fraction. What percent of 350 is 50? 50 is what percentage out of 350? 0.14285, and it keeps going. So I'm going to say 14.3%. I'm going to round it. If you have any questions, let me know.